Hello, wonderful students. Welcome back to another day of physical science. Today we're going to be practicing the scientific method a little bit, and this is definitely going to tie into the experimental design stuff that we've been doing. So here we have this experiment given to us. It says Marie and Pierre, who are famous scientists, are trying to decide if they should buy the generic Ziploc bags or pay the extra money for the higher end Acme zipper gripper bags for lunches. So Pierre thinks that the bags are equal in strength. Marie contends that the more expensive Acme bags are stronger. So to test this, they fill each brand with equal amounts of water, and Marie drops the bags from changing heights until the bags burst. The bag that tolerates the longest drop should be the strongest bag. So they repeat the experiment 5 times for each type of bag. And then it gives us this table here. So we have 5 different trials: generic Baggie, and then the Acme zipper gripper bags. And then they give us the different height that they were able to drop it from before it burst. So they may have dropped it from other heights, but this is the height that the bag finally broke open with once it was filled with the equal amounts of water. So first thing here, just asks us to state, what is the purpose of this? The purpose of this experiment, from the sounds of it, is to determine strength of 2 different bags. Different bag types, something along those lines. And then it says, what is Pierre's hypothesis? So anytime we do this, I really need to reiterate that we do use these if, then, because statements. So if this happens, and please remember, I gave some notes yesterday in one of our other video lessons that your if statement should always relate to your independent variable. Your then statement should relate to your dependent variable. And then your because statement is, whatever logical reason that you can give. So here would be some examples, or here would be an example of Pierre's hypothesis. So if the generic bags are equal strength, right, we have to do something around the independent variable. So the independent variable, that is, again, what the researcher changes. So what are they changing in this case? Well, they're changing the bag type. So that's why our if statement has to relate to our independent variable, so what the researcher changes. Our dependent variable is our then statement, right? If this, then our dependent, what it depends on, then, which is always going to be what the researcher measures. So what are they measuring in this case? Sorry, this app glitches sometimes. So what the researcher measures, well, in this case, they were measuring, right? They have these different burst heights here. So they measured the height that the baggies burst at. So if the generic bags are equal strength, then they will burst at the same height because dropping tests the strength of the bags. Okay, again, I would pause the video now and see if you can write Marie's hypothesis, making sure that your if statement relates to the independent variable, then statement relates to the dependent variable. So a good example of Marie's hypothesis would be if Acme bags are stronger, then they will take more height to burst because dropping height tests the strength. So whose hypothesis does the data support? Well, if we look at it, we can pretty strongly see that the Acme bags took more height. And we're not going to say prove. Remember, in science, we're really not proving any of this. We have a lot of data to support it. Stuff has to be done, 100 times. It has to be peer reviewed. It has to be done over and over and over. So in this class, unfortunately, you're never going to prove anything. You can have your data supported. So whose hypothesis does the data support? It is going to support Marie's hypothesis in this case, that the Acme bags are stronger. So what is the independent or manipulated variable? Well, since we said if Acme bags are stronger, so again, just going back to this, it would be the bag type. Dependent or responding variable is burst height. So how high did the bags drop from before they burst? Name at least two different constants. So there's one that it gives us that's pretty obvious. They fill each brand with equal amounts of water. So we can say amount of water. And then again, I'd like to make you kind of think on it a little bit. But one that we could say is probably, because sometimes we have to make some assumptions to it. So name two constants. One would be the amount of water. The other could be probably the person dropping the bag. You could probably assume that they were using the same measuring device, right? I doubt they're sitting there changing the ruler or whatever that they use every time to measure the height. So those would be some examples of constants. And write an appropriate conclusion based on Marie's hypothesis. You could say something along the lines of, based on the evidence, the Acme bags are stronger because they took more height to burst. Again, we didn't prove that, but the data supports it. So going on to the next page now, we have this word bank here. It says words may be used more than once or not at all. We have a lot of different words to figure out here. So I won't be writing out the definition for all of them, but that's pretty much what we're going to get as we fill in the blanks. So again, what I would do, pause the video, try to do this completely on your own, right? That's what's going to help you for the test. That's what's going to help your understanding. And then make sure that once you've tried to completely do this on your own, you can hit pause, you can fast forward a little bit until all the answers pop up so you can see what you got. And then I would come back, any of them that you got incorrect, I would go back and watch and listen for the explanation. So let's go ahead and start on this. So the blank is the part of the experiment that you compare your results to. So whatever you're using for comparison, right, this actually goes back to like the paper airplane activity. Well, what did we compare if adding, I think I added staples to the airplane. So what did I compare that to see if it made a difference? Well, I compared that to the regular paper airplane. So in this case, that is going to be compared to your control group. So the control group is what you are going to compare to. The blank describes the steps you use during an experiment. So I haven't probably, or maybe I have formally taught this, but you see it on almost every lab that you do. You saw it even in the paper airplane activity. It had a really short procedure. So the procedure tells you the steps that you take during an experiment. After an experiment, scientists write we actually just did this. On the previous page here, write an appropriate conclusion based on Marie's hypothesis. So after an experiment, we write a conclusion which summarizes the data or the findings. The blank is a process used by scientists to find answers to questions or solve a problem. So this is actually called our scientific method worksheet. So that is the scientific method. So that's the process that is used to determine and to conduct science. The blank is the part of the experiment that is being tested, or the part that is changed by the person doing the experiment. That is being tested or changed. We actually wrote a note about this on the first page. What the researcher changes, so that is your independent variable. Your if statement always relates to your independent variable. If they change the bag type. So it is the independent variable. The blank is an educated guess, typically written as if, then, because. Again, we just saw this on the previous page. When we wrote an if, then, because statement, that was for a hypothesis. So the hypothesis is an educated guess. Scientists use their data to make charts and blank to communicate the results of an experiment. So scientists are going to use charts, and if we look at all the words up here, some of them are kind of weird to choose through, but we do have the word graphs. Again, we haven't done that in this assignment, but that's all right. So they make charts and graphs often to communicate the results of an experiment. After the scientists make a hypothesis, they perform an experiment. Experiments are where they're going to get their data from. And you did that again. Paper airplane activity, right? We throw that plane, we collect the data of how far the plane flew. The first step of the scientific method is to find or identify, and we've done this on many assignments, or sometimes it's given to you, but you state the problem, or you could call it the purpose. And so looking up top here, I think we use the word problem in this case because I don't think we have purpose up here. So the first step is to identify the problem. What are we even trying to do in this experiment? Sometimes scientists make a mistake or an error. So this goes back again. I know I referenced paper airplane activity a lot, but when you take that paper airplane, right, we have to control for a lot of things. We have to control for the strength that we throw it for, the angle that we throw it at. We have to make sure there's no wind that's going to affect it. You got to control as much of this as you can. But most experiments are not going to be perfect, and you're going to have some sort of error in there. The blank is the part of an experiment that is affected by the independent variable. Typically what the researcher is measuring. Well, going back to this again, the then statement, which relates to your dependent variable, is what the researcher measures. So that is your dependent variable. During an experiment, everything that stays the same from one trial to the next is a constant. Again, paper airplane activity, we wanted as many constants as possible. Throw it with the same strength, throw it at the same angle, try and not have wind down, make sure you start standing in the same spot. So you want as many constants as you can. Any data that is collected that is described in the experiment is, and we may not have talked about this a whole lot yet, but that's okay. We're kind of introducing words here. Any data collected that is described in the experiment is qualitative data. And the way I always explain this to students, right, it says describing the experiment. Think of that like qualities. And then the next one is using numbers. So numbers is like a quantity, so that is quantitative data. And so again, quant, which basically means like quantity. So if you go to the grocery store and you buy something and ask like what quantity you want, so quantity, or I guess numbers. And there we go. That is our scientific method worksheet. Thank you for following along and learning with me. If you have any questions, just make sure to reach out.